Hey, if you're gearing up for the Google Professional Cloud Architect exam, you already know that some topics are just bigger than others. So today, we are diving deep into the absolute cornerstone of cloud security, Google Cloud IAM. If you can master this, you're not just prepped for the exam, you're ready to build a cloud that's actually secure. So let's just kick things off with a really important question. When you see those scary headlines about big data breaches in the cloud, what's the first thing you think of? Super sophisticated hackers in hoodies? Some kind of crazy, complex exploit? Well, the real answer is probably a lot simpler than you think.
Yep, that's it. The number one cause, time and time again, is just simple mistakes in permissions, giving the wrong person or the wrong application too much access. And that's why IAM isn't just another line item on the exam syllabus, it's the very foundation of your entire cloud security strategy. Getting this right is completely non-negotiable.
So here's our game plan for today. We're going to start with the basics of IAM. Then we'll get into the golden rule, the principle of least privilege. From there, we'll talk about identities, not just for people, but for apps, which is huge. Then we'll see how to use GCP's structure as a safety net, touch on some pro-level moves, and wrap it all up with a summary that's perfect for your exam prep. Let's get into it.
All right, first things first. Let's be super clear about this. Identity and access management, it's not just another feature you can turn on or off. In Google Cloud, it is the security. Every single thing you do, whether it's firing up a virtual machine or just reading a single file from a storage bucket, has to get the green light from an IAM policy. Full stop.
And that brings us to maybe the single most important idea in all of IAM. You're going to see this pop up over and over on the exam, and you'll hear it constantly in any real-world security chat. It is the golden rule, the principle of least privilege.
The idea is actually pretty simple, but it's so powerful. You only give an identity, and that could be a person or an app, the absolute minimum permissions it needs to do its specific job, and nothing more. The whole goal is to shrink what's called the blast radius. So if an account ever gets compromised, the amount of damage a hacker can do is tiny.
Okay, so how do we actually do that? Well, this slide breaks down your toolset perfectly. You've got three types of roles. First, primitive roles, like owner or editor. These are, well, they're dangerous. Think of it as giving someone the master key to the entire building. Then you have predefined roles. These are your best friends. They're granular, Google manages them, and they should be your go-to choice 95% of the time. And finally, custom roles, or what you use as a last resort, when even a predefined role is a little too generous.
So here's the absolute key takeaway for the exam. You're going to get scenario questions, and they'll ask you to pick the right role. The answer is pretty much always the most specific, most granular, predefined role that gets the job done. If you see owner or editor as an option for anything in production, warning bells should go off. It's almost definitely a trap.
Okay, let's move on and talk about the identities themselves. Because, we're not just managing access for people typing on keyboards. We also have to manage access for our applications and our code. And honestly, this is where a lot of security plans just fall apart.
So let's talk about a service account. It's basically an ID badge for your code. When a VM needs to save a file to a storage bucket, it's not you doing it. It's the virtual machine itself. And that VM needs an identity and it needs permissions. That's a service account. It's a non-human user, and it has to play by the exact same rules of least privilege. And this quote, this really hits on the single biggest danger with service accounts. For a long time, people would just download a key, it's this little JSON file with a permanent password, and stick it right in their application's code. This is, and I'm not exaggerating, a ticking time bomb. Because if that key ever leaks, and trust me, they do, an attacker has a permanent key to your kingdom.
So let's compare the bad old way with the modern, much more secure way. Instead of those static, permanent keys, the answer is something called Workload Identity Federation. Think of it this way. Your app, wherever it's running, AWS, Azure, your own data center, can securely prove its identity to Google. And in exchange, Google gives it a temporary, short-lived access token. No permanent keys to leak, no manual rotation. It's a game changer.
And here is another huge exam tip for you. Write this one down. If you get a question and it's a scenario about an application running outside of GCP that needs to access Google Cloud resources, the answer is almost guaranteed to be Workload Identity Federation. It is the modern, secure answer to that classic problem.
Okay, so we've talked about who gets access. Now let's talk about where they get it.
because the way you structure your entire Google Cloud environment can actually be a really powerful security tool all on its own, all thanks to hierarchy and inheritance.
See, in GCP, everything fits neatly into a hierarchy. You've got the organization at the very top, that's your whole company. Under that, you can create folders for, say, different departments. Inside those folders are your projects, and inside the projects live your actual resources. And the most important rule here, permissions flow downhill. If you give someone a permission at the folder level, they automatically get it on every single project and resource inside that folder.
And this leads us to a rule that you absolutely have to burn into your memory. IAM policies are additive. What that means is if a user inherits a powerful role from a folder above, you cannot take that permission away at a lower level, like inside a project. You can only grant more permissions. Inheritance is a one-way street. You can't block it.
Now, since you can't block inheritance, how do you enforce rules everywhere? Well, that's where organization policies come in. It's so easy to get these confused with IAM, but they're totally different. IAM answers who can do what. It grants permissions. Organization policies answer what is even allowed to happen here. They set up guardrails. So you could create an org policy that says no one is allowed to create those dangerous service account keys, period. And not even a project owner can get around that rule.
So we've got the fundamentals locked down. Now, let's level up and look at a few advanced plays. These are the tools you'll pull out when you need to really fine-tune access for your most sensitive stuff.
We've got three key concepts here. First, separation of duties. This is the idea that no single person should hold all the keys. For example, the person who can spin up resources shouldn't also be the person who pays the bills. Next, MFA. This is just a must-have for your important accounts, adding that second security checkpoint. And finally, IAM conditions, which let you get super specific about when and how someone can get access.
Let's just walk through how a condition actually works. It starts off like a normal IAM policy, right? You've got a principal, a role, and a resource. But then you add the magic ingredient, the condition. In this case, our developer can only view these reports if the request happens during business hours. How cool is that? You can base these on time, on location, on the type of device they're using. The possibilities are incredible.
Whew! Okay, we have covered a ton of ground. So let's bring it all home. We're going to distill everything down into the key, actionable things you absolutely need to know, both for the exam and for building truly secure systems.
Here it is, your 5-step IAM sanity check. Number 1, least privilege always. Start with predefined roles. Number 2, centralize your identities so you have one place to manage users. Number 3, audit, audit, audit. Use tools like IAM Recommender to clean up old permissions. Number 4, no static keys. Just don't do it. Use Workload Identity Federation. And number 5, use that hierarchy. Let folders and org policies be your security guardrails at scale.
And we'll end on this thought. After all this, from least privilege to org policies, the real goal is to get to a point where your cloud is secure by design, not by accident. When you proactively use these IAM principles, you're building an environment that's strong, that's manageable, and that's fundamentally secure right from the ground up.